Hi guys, let me take a few minutes to take you through the first three multiple choice questions. Number one, what is the expected number of cars in a randomly selected American household? So the key is this expression right here, expected number. That's the same thing as the expected value, or mu. So what we want to calculate is the sum of every outcome multiplied by its probability. So here we go. It's not a binomial random variable. This is a random variable that is outlined in a table, so we can't do n times p. So this is the more generic relationship here when we have a discrete random variable. So the truth is, it's every outcome multiplied by its probability. This is something we see actually pretty typically on the AP exam, and it's important that you show your work on a question like this. Certainly not if it's a multiple choice question, but otherwise, if it were a free response question, you want to show that you know to take every outcome multiplied by its probability. Here's the outcome of 1 multiplied by its probability, plus the outcome of 2 times its probability, 3 times its probability, 4 and its probability, and the last outcome, 5 times its probability. So that's what the work would look like. If you simplify that, you will get B. That answer is 1.75. Some of you might recognize that we have a calculator program that we wrote a while back that we could actually use to do this also. So if you press Stat and Enter, I have already entered the outcomes into list 1 and the corresponding probabilities into list 2. So back to the home screen, if you press the Program button, you can run the program RVMVS. That stands for Random Variable Mean, Variance, and Standard Deviation. And there is the mean of 1.75. Here is the variance. And then here's the standard deviation, 1.08. The standard deviation is actually given to you in the next question, but this is actually where that standard deviation comes from. So question number 2. The standard deviation is 1.08. If many households were represented at random, which of the following would be the best interpretation of that value of 1.08? So that answer is B. So this is the number of cars. They would typically be about 1.08 from the mean. So this gives us an idea of what is typical, the mean of 1.75. If you add 1.08 to that or subtract 1.08 from that, that gives us an idea of what is typical. So easy to be fooled on a question like number 3 about what percentage of households have a number of cars within 2 standard deviations from the mean. Now be careful, the answer is not D. If we have data that are normally distributed, approximately 95% of the data are within 2 standard deviations of the mean. But these are not normally distributed data. These are data that are simply represented in a table. So what we actually need to do is calculate those boundaries. So let's take the mean that we've already calculated of 1.75, and let's add 2 standard deviations to that. So that will give me an upper boundary. Similarly, let's take 1.75 and subtract 2 standard deviations from that. That will give me a lower boundary that will capture 2 standard deviations above and below the mean. Let's actually calculate it here. So here is the 1.75 plus 2 times the standard deviation of 1.08. There we go, 3.91. So if I press second enter, it will call back the previous command, and I'm just going to go and edit it. So instead of adding the 2 standard deviations, I'm just going to subtract them. So there's my other boundary, negative 0.41. That's the lower boundary. The upper boundary is positive 3.91. Those are actually the cutoffs that represent 2 standard deviations below the mean and above the mean. So now what I can do is go to my discrete random variable. Notice the 3.91, that's just a little less than 4. So that would not include the outcome of 4. It would include outcomes below it. The negative boundary of negative 0.41, that's, of course, not possible. So that means that at the very lowest I can go is a count of 0. So the outcomes 0, 1, 2, and 3, those are the only outcomes in this table that are in between negative 0.41 and 3.91, which is 2 standard deviations below and above the mean. So to get the answer, you simply add up the probabilities for 0, for 1, for 2, and for 3. The sum of those is 0.93. So that gives you answer C. About what percentage of households have a number of cars within 2 standard deviations from the mean? About 93%.